Our question is, a man invests €40,000 in ACME shares at the beginning of 2005. The stocks rose by 12% per annum for each of the next 3 years, and then started to decrease by 16% per annum. Part 1 of the question: what was the value of the shares at the end of 2007? And Part 2: if the value of the shares continues to decrease at 16% per annum, when will they have dropped to their original 2005 price? Tackling Part 1 first of all then. What was the value of the shares at the end of 2007? So to do this, we're going to use a very simple formula. V equals P upon 1 plus I to the power of T, where V equals the value of the shares, P equals the investment amount, I equals the interest rate, and T equals time. So V is what we're trying to determine in this part of the question. P is equal to 40,000. I is equal to 0.12, which is the decimal equivalent of 12% increase. And T is equal to 3 years, because we're going to the end of 2007. So subbing our values into the formula then, we have V equals 40,000 upon 1 plus 0.12 to the power of 3. That's equal to 40,000 times 1.12 to the power of 3. And determining that V value then, it's equal to 56,197.12. Therefore, the value of the shares at the end of 2007 is €56,197.12. Okay, moving on to part 2 then. If the value of the shares continues to decrease at 16% per annum, when will they have dropped to their original 2005 price? Now to do this, we're going to use the same formula. V equals P upon 1 plus I to the power of T. Everything's the same here, so V is equal to the value of the shares, P is equal to the investment amount, I is equal to the interest rate, and T is equal to the time. So V is what we're trying to determine. So we can see here it's the original 2005 price, so it's 40,000. P is what we've determined there in part 1, which is 56,197.12. I now is equal to negative 0.16 because it's a decrease of 16% per annum, and T is what we're trying to determine. Okay, so I've written the equation out again here. V equals P upon 1 plus I to the power of T, and this T is what we're trying to determine. So what we're going to do is just reorganize our equation here so we can get T on the right hand side on its own. So our first step is to divide by P. So we get V over P is equal to 1 plus I to the power of T. The next step then is to take the log of both sides. So we have the log of V over P is equal to T upon the log of 1 plus I. Now how we got the T down there is just using the power rule. Now here's the equation again. Log of V over P is equal to T upon the log of 1 plus I. Subbing in our values then, we have the log of 40,000 over 56,197.12 is equal to T upon the log of 1 minus 0.16. So that's just equal to the log of 0.84 here. Calculating that 40,000 over 56,197.12, this is the full calculator display, okay? So we have the log of 0.711870,247 is equal to T times the log of 0.84. We're writing out the full calculator display here because we want as little rounding error as possible. So the next step is to divide by the log of 0.84, and that's giving us T on the right hand side on its own, so we can determine our time. So the log of 0.711870,247 over the log of 0.84 is equal to our T value. Determining that value then, we get T is equal to 1.9499 and so on. On your calculator you'll have the full display there. But it's approximately equal to 2 years. Now, what that means is therefore it will be the end of 2009 when the shares dropped to their original price. So we had an increase for 3 years, which was part 1 of the question, and then we had a decrease, which was determined here for 2 years, which brings it to 2009 when we're back to our original price of the €40,000 investment.